So this is the Precalculus unit exam on Chapter 1 of CPM Tools, version B. Okay, version B. So number 1, we were given a function, right? We were given h of x is equal to absolute value of x plus 3 minus pi. Okay? So we were asked to A, state the equation of the parent graph, and B, describe the transformations from the parent graph. Okay? So to get the parent graph, we take away any shifts, stretches, reflections, any transformations. So we take away the pi over here, we take away the 3, and we're left with just y is equal to the absolute value of x. Okay? You could even say h of x is equal to absolute value of x. This is the parent function, the absolute function, right? So that was part A. Part B asked then, what are the transformations that took place? Well, this plus 3 we know is within the argument, right? You could even put a parentheses around that. And what is that going to do? That's going to horizontally shift left 3 units. Okay? And that happens before this, which is going to outside the argument. That's a vertical shift down pi units. Okay, if you were not comfortable with pi, you could have said 3.14 approximately, right? But do not say this is 3 or something else. It's not stretching, this is just shifting, right? And 3.14 units or pi units exactly. Okay, so let's go on to number 2. Let's box our answer for part B as well, because I asked specifically to box all your answers. So number 2. Number 2, we were given f of x is equal to 2x plus 5, and g of x is equal to the square root of x minus 5. Okay. Part A, we were asked to find the composition f of g of x. This is not multiplying. This is the input of f is a function g. Okay. So what we do here, remember, is this is equal to f. We ignore that. We just look at the inside. We replace g of x with what is defined to be square root of x minus 5. We no longer write g, we no longer write anything but what is defined to be on the right. Okay, these are equal, so these are equal. Okay, the next step then is to look at function f of x, right? And we know that f of x, wherever x is, we have 2 times x plus 5, right? So what we need to remember to do then is this is the new input, the new, instead of x, this is the new input. So we multiply 2 times whatever that input is plus 5. So we just place the square root of x minus 5 here, right? Because that's what the input is. Okay? You cannot distribute the 2 inside the square root. So the answer is just 2 square root of x minus 5 plus 5. That's it, right? If you really wanted to distribute the square root, the 2 inside, well, you could do that, but you would have to make it a square root as well. So what could you do? Well, if you want to square root something and that's equal to 2, well, that's 4. The square root of 4 is equal to 2. So you could do this, right? Then once you do this, now you can distribute that 4 inside and it can share the same root, right? Because they're both the square root. And now you can distribute that 4 in and it's 4x minus 20 plus 5. Okay? You could do this, but in reality, this right here is the simplified answer and you're done. Okay? You cannot just distribute that 2 in. It's not going to work. If you want to, you have to make it the 4. Okay. So part B. Part B asked us, find the inverse function of f. Okay, and the hint said unwrap. Because basically to find the inverse function, you look at 2 things. One is how did you wrap function f of x. So you start at y is x, then you multiply by 2, right? And then you add 5. This happened in this order, right? You multiply by 2 and then you add 5. So to unwrap it, you do the opposite in the opposite order. Okay, make sure you do the opposite in this order. So start with y is x again. What's the opposite of adding 5? Subtracting 5. What's the opposite of multiply by 2? Well, you always take the whole thing, do whatever you do to it. So it's not multiply by 2, it's divide by 2. Okay, and then you're done. So that's the inverse function of f, right? And box your answer. Okay, so let's go on to number 3. Number 3, we're given a function f of x. Okay, so I'm going to try and sketch it. Whoa, this is number 3, right? Here it had a point, and negative 1, 2, 3, down 1, right? And down like this. Okay, so you have this 1, 2, 3, 4, right? It goes to negative 1 here and passes. Okay, so this is the original function f of x here in red. And we were asked then to sketch negative f of x plus 3, right? So what you have to remember, all this is doing is plus 3 here means shift to the left by 3, shift horizontally left 3 units, right? And then this we know is going to do reflect across our x-axis. Okay, so I'm going to do this in 2 steps. The first one, I'm going to shift left. Okay, I just want to make sure everyone sees it. So everything shifts to the left. Remember, left is that way. So we shift left by 3 units, right? So we're looking like this. 1, 2, 3, more like this. Okay. That's our shift left 3 units. Okay, every point is going over 1, 2, 3, 1, 2, 3. This point goes 1, 2, 3. Okay, then reflect across the x-axis. That means every point here reflects all the way to the other side of the x-axis, right? Every point here reflects to the other side of the x-axis. No, I'm doing the yellow one. So this one goes now up, right? So this is our new function. Right, so this is negative 2 here, yeah. And now it crosses this point here, like that. So in green is the reflection and the shift left, okay? So in green is both, and I'm done now with number 3. So let's move on to number 4. Okay, so number 4 asked us to solve for the missing value of side x in this triangle. Right, we were given a triangle. This is side x. This is 112 degrees. This is 33 degrees. This is 20. This is side 20. Okay. Most helpful thing to do first is label it. Okay. Label it A, B, C, any direction you want. Opposite of B is little b. Opposite of A is little a, little c. Okay. So what should you have done first? Well, if you want side x, how can you get it? Well, we have the law of sines and the law of cosines, right? So the law of cosines requires us to have the other 2 sides, right, and the angle across. We do not have the other angle or this side, okay? The law of sines requires us to have an angle and the side opposite and an angle and the side opposite. So we don't have that either. Well, what you need to realize then is we need angle B, right? How can we get angle B? Well, angle A plus angle B plus angle C equals 180 degrees. Okay, plug those in. Solve for B. You get angle B is 35 degrees. Okay, I already did it, so I'm just skipping that work, but go ahead and do it. Okay, so you get angle B is 35 degrees. Now I can see I can use the law of sines. Sine of angle B over B is equal to, right, sine of B over side B is equal to sine of A over side A, right? And I could just plug that in. Sine of 35 degrees over, well, x, what I want to solve for, is equal to sine of 112 over 20. Okay? And you could have done this now with, you could have used like other methods to, some people solve for side C and then use the law of cosine, or you could directly use the law of sines to solve for x, right? Some people use the law of sines to solve for C first, which was extra work, but you can do it that way. Okay, solving for x. Multiply both sides by x to get it out of the denominator. These then cancel, right? Multiply both sides by 20. By 20. Then these then cancel, right? Divide both sides by sine of 112 degrees. Then these cancel. Okay, so let me rewrite that neatly. It's 20 times sine of 35, right? The rest just cancels out, over sine of 112 degrees. On the right, we just have x. Okay, plug this into our calculator. So we have 20 times sine of 35 divided by sine of 112. Make sure I am in degrees mode. Enter, and so x is approximately 12.37 units. Okay, box my answer, and I'm done. Alright, so that is number 4. Let's go on to number 5. Number 5 gives us 2 different angles. So start with 5A. So here's the circle, right? And we are given, this is the unit circle, we're given the angle that ends right here. Okay, I might have drawn it not as well as the computer generated version on the test, but you get the point. So these are special angles, meaning this is either going to break it into half or into 3, right? And we see that it breaks it into 3 because half would have been right in the middle. So this is 3, and we know that one of those is pi over 6. So we start here at 0, positive pi over 6, positive 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, done. Okay, this is radians already, and we're done. Okay? 5b. 5b asked us to look at this unit circle again with a different angle. Okay, the angle was right here. It split it in the middle now. Okay, and it went in this direction. Clockwise means negative. Okay, so what we have to remember now is that when we split these into 2, this is pi over 4, right? So if we start here, right, and go this way, this is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, done. Okay, this is already in radians. Box your answer. You're done. Okay, number 6. Number 6 had A and B. We were asked in A to convert 285 degrees into radians. You have to remember that 360 degrees equals 2 pi radians, or 180 degrees equals pi radians. Okay, so then we want to multiply by the conversion factor. So degrees in the denominator, radians in the numerator. So degrees cancel, 180 and pi, or you can use 2 pi and 360, right? Remember, this is over 1, so you just multiply across, 285 pi over 180 radians. Simplify that, you get 19 pi over 12 radians, right? Plug that into your calculator. I already did it. You get 4.974 radians approximately. Okay, you could have plugged this into your calculator. We got the same thing. Both of these answers are completely simplified and great. 19 pi over 12 radians are 4.974. Okay, let's go on to 6b. 6b. We were asked to convert 4.7 radians into degrees. Okay, remember this is over 1. This is not 4.7 pi radians, just 4.7 radians. So we multiply this, we went radians in the denominator, degrees in the numerator. Okay, so pi radians equals 180. Multiply this across. 180 times 4.7, put in your calculator, is 846. And we have pi in the denominator, degrees. We're done, or we could plug this in our calculator. It's approximately 269.29 degrees. Either one of these is acceptable, okay? And we would have been done. All right, number 7, factor completely. This was taken from section, so 7 was taken from section 1.4 quiz exactly as is, not changed at all. And that video is up already, so I'm not going to redo it here, okay? So you can look at section 1.4 quiz, and you'll be able to see number 7. All right, so this ends the CPM Chapter 1 Tools exam from Precalculus. Remember, it's version B.